Hello everyone, welcome to Lesson 7 in Math, it's decimals. Today we're going to learn to round decimals, compare decimals, multiply decimals, and also divide decimals. Part 1, rounding. So when you're rounding, the rule is if the digit in the next place value is 5 or higher, then the digit increases, and if it is less than 5, then the digit stays the same. And after you round, you don't need to write the numbers after the place value that you just rounded. So first of all, before we go on to an example, let's get a refresher on what the place values are. So the digit before the decimal is going to be the ones, or if you have anything before that, like in this case, there's only a 5, so that's going to be a ones. But if there was something before the 5, for example, 1, so if it was 15, then the 1 would be the tens. And after the decimal, the 3 is the tenths with a THS. The 7 would be the hundreds, the 8 would be the thousands, 2 would be 10,000s, 1 would be 100,000s, and if we say there was another digit after 1, for example 5, then the 5 would be the millions. So example, and we're told to round to the nearest thousands. So here's our number. And if we look at our chart, the thousands would be the third digit after the decimal. So in this case, the 8, and it's already highlighted for us. And so we look at the next number, just like our rule tells us. We look at the next digit after 8, and it's 7. 7 is greater than 5, so it's going to make 8 increase by 1. So therefore, our final answer would be 2.939. And a better way to say it instead of 2.939 would be 2 and 939 thousandths. And here is another example. So our decimal is 5.34567, or 5 and 34,567 hundred thousandths. And so here in the thousands, we look at, okay, so we want the third digit, which is 5 in this case. We look at 6, which is the next digit. It's greater than 5, so the 5 is going to increase by 1, and therefore our final answer is going to be 5 and 346 thousandths. The next is hundreds. So you look at the 4, that's what we're solving or trying to round. And next digit after 4 is 5. 5 is 5. And according to our rule, if the place value is 5 or higher, then the digit increases. So 4 is going to increase by 1, and we will get 5 and 35 hundredths. If we're talking about the tenths, we're basically talking about 3. So we're looking at 4, and 4 in this case is less than 5, so 3 is going to stay the same. So our final answer is 5 and 3/10. And our whole number in this case is 5. And also, as you can see, I also implemented this rule where you don't continue to write the numbers after the place value you just rounded. So in this case, when I was rounding to nearest thousands, I did not write the digits after 6, or like in this case, I didn't write the 10,000s and the 100,000s. And same thing with hundreds. I just stopped at hundreds and I didn't continue to thousands and 10,000s and etc. Part 2, comparing decimals. Signs of comparing decimals. So here, this is something that I struggle to keep in my head as I was growing up. But we always read from left to right. That's the key on how we remember what these signs are. So if there's a number right here, and there's obviously something after it, you're comparing it and saying, okay, is this number greater than, less than, or equal to the number, towards the right? And if it's greater than, then you would use this sign where it's kind of like a crocodile or an alligator's mouth, I guess. The side that is open would be to the greater number. If it's less than, then obviously we're reading it from left to right again. So the number here would be less than the number here. And you're putting the less than sign because this number is smaller than the other one. And so the crocodile's mouth is always going to follow the bigger number. And equal to, well, it's equal to. The tip could be read it like money as well when we're comparing decimals. And when we're comparing decimals, some steps are first begin by comparing the first digit. But if the first digits are the same, you can move on to the second digits and compare them. If the second digits are the same, then you move on to the third digits and so on until you are able to compare the two decimals so that it doesn't look like they're equal. And then here's an example. So for example, 9 and 54 hundredths, and we're comparing that to 9 and 798 thousandths. Well, what you could do, okay, so the first digits are before the decimal is basically the ones, and the nines are both equal. So let's move on to the next digit. And the next digit is 5 and 7. Okay, so 7 in this case is greater than 5, obviously. So we can stop there. We don't have to continue comparing 4 and 9 or so forth. So once you know that, okay, for example, 7 is greater than 5, then you already know which number is greater than or less than the other one. So in this case, again, reading from left to right, 9 and 54 hundredths is less than 9 and 798 thousandths. And then when I was talking about a tip could be like reading it like money, well, you could say, okay, $9.54 and compare that to $9.80 for say. Because if you basically round 79, it could be 80. So $9.54 is less than $9.80. And here's some practice. It's not a lot of questions, but I've done the first one for you. So $1.77 or 1 and 77 hundredths is going to be greater than 1 and 7 tenths or $1.70. Remember, like there's an invisible zero there. So if that helps, you can always include it. But even if it's 1.7, just know there's going to be an invisible zero. So it's like 1 and 7 tenths or 1 and 70 hundredths. It's the exact same thing, doesn't matter. And why don't you try this one for yourself? Part 3A, multiplying decimals. So multiply as if there are no decimals. Then at the end, count the number of digits on both factors after the decimal and go to the left of the product that many times. So let's take a look at this example before we do the practice questions. Again, this is long multiplication, so just as a refresher, you're going to be multiplying the top number by every digit of the second number or factor. And also, in this case, remember, pretend like there are no decimals, pretend the decimal signs don't exist. So 1 times 1 is 1, 0 times 1 is 0, 0 times 1 is 0, and 1 times 1 is 1. Moving on to the next digit of the second factor, which is 0, and that's in the tenths column. So 1 times 0 is 0, 0 times 0 is 0, 0 times 0 is 0, and 1 times 0 is 0. Moving on to the third digit, which is basically the ones in this case. So 1 times 1 is 1, 0 times 1 is 0, 0 times 1 is 0, and 1 times 1 is 1. Now that we're done multiplying, we can add to get to our final answer. So there's nothing to add the 1 with on the very right, so we just bring that down. 0 plus 0 is 0, and 0 plus 0 plus 1 is 1, 1 plus 0 plus 0 is 1, 0 plus 0 is 0, and you just bring down the 1 on the very left. And so now the next step is you're going to count the number of digits on both factors after the decimal and go to the left of the product that many times. So in this case, look, we go back to the top and we say, okay, on both factors, meaning 10 and 1 hundredths and 1 and 1 hundredths, how many digits are after both decimal points? So in the first factor, there are 2 digits after the decimal point. In the second one, same thing, 2 digits after the decimal point. So that gives a total of 4 spaces. So we're going to go back to our final answer, and we're going to go 4 spaces to the left. So in that case, we would get a final answer of 10 and 1,101 10,000ths. And here are some practice questions for you, and I'll put the final answers in the description box. Part 3B is dividing decimals. So this is the same as dividing whole numbers by pretending the decimal is not there. The steps are, you put the decimal on the answer line, and then you divide normally using the acronym DMSB, which stands for divide, multiply, subtract, and bring down. And those are the steps we use for, traditional long division. Here are some practice questions for you, and I've done the first one for you. So 28 and 60 hundredths divided by 3. The first step is to put the decimal on the answer line. So you're going to put the decimal point exactly above where the decimal point of 28 and 1600ths is. Then you would divide normally using DMSB. So 2 can't go into 3, 28 can go into 3 9 times. So 3 times 9 is 27. You subtract that and you get 1. And then you bring down the 6, and then it would be, so 0, 1, 6, or 16. And then you say, okay, how many times does 16 go to 3? You would say 5 times, so 5 times 3 is 15. Subtract that, and you still get 1, and you bring down the 0, and then it would be, how many times does 10 go into 3? Well, it goes 3 times. 3 times 3 is 9, and 10 minus 9 is 1. So basically, we could continue to get a bigger decimal, but in this case, I'm just going to stop there, and I'm going to say 1 will be the remainder. So we would say 9 and 53/100ths, remainder 1. And try the next one for yourself. I've already given you some hints. I've told you what the final answer will kind of look like, and in each step, how many digits there will be. Okay, so this was our lesson for decimals and lesson 7. Hopefully it was pretty straightforward and easy. I wanted to put all of them together, so like rounding, comparing, multiplying, and dividing. Obviously adding and subtracting is pretty straightforward. I'm sure that you would know that at this point if we're multiplying and dividing. But this was our lesson for today, and hopefully you were able to understand it. Thank you for watching, and I'll see you in the next one.